Okay, so this is the final video of this prep. It says some cumulative binomial distributions are given below. So this is this table, and you actually get to use one of these. You'll see lots of these. And it's a table for a binomial distribution that's with 9 trials, so 9 coin flips. And there's a grid of numbers for each for one of a large number of possible probabilities. So if you had a chance of your coin coming up heads, or a chance of a success in your trial of 0.1, then this part of the table would give you the probabilities that capital X is less than or equal to little x for the different values of x going down. So we'd say the chance that in that type of situation, the chance that x is less than or equal to 3 is 0.9917 to 4 decimal places. And the reason it's to 4 decimal places, that's why we see these 1s coming up here. So what it's saying is that if you've only got a 1.1 chance of success, the chance of getting less than or equal to 6 successes out of 9 trials is so close to 1 that there's no difference to 4 decimal places. Okay, so with that in mind, why don't you pause the video now and have a go at finding these 5 probabilities. Think carefully about them. The numbers in the tables, I'll just write it again, they give you in red the probability that x is less than or equal to capital X. That's what you find in the tables. How can we use it to fill in these 5 things? So do pause the video now, have a go. Okay, so it says that x is binomial 9 trials, probability of success 0.3, so we're looking at this column here, so I might just sort of scribble out the columns on the side so we don't get confused by it. Okay, so we're focused in on that column between the green scribbles, as it were. Okay, so the chance that x is less than or equal to 4, we can just read off the table. It equals 0.9012, okay, or 0.901 to 3SF, and that's a good habit when using these tables to give you a final answer of one less significant figure than the tables are given. Chance that x is less than 3, the crucial thing is you have to be very careful that that's the chance that x is less than or equal to 2. So that's 0.4628. The chance that x equals 3 is a very cunning trick here. You say chance that x is less than or equal to 3 minus the chance it's less than or equal to 2. So that's 0.7297 minus 0.4628. Okay, which equals 0.2659. Now, you could check that. In fact, let's quickly check. You could check that directly using the formula, or using this idea that the probability that x equals 3 is exactly 9 choose 3 times 3 successes, that's 0.3 to the power of 3, times 6 failures, 0.7 to the power of 6. And if you tap all that into your calculator, you should get a number that's roughly 0.2659, because that is how this table that we've got on the screen box was actually constructed. The formula here was used for all possible values, and they were added together to give this cumulative thing. The fourth question asks for what's the chance that x is greater than or equal to 2, and that's equal to 1 minus the probability that x is less than or equal to 1, which is 1 minus 0.1965. And so that's equal to 0.804. Sorry, I'm running out of space there. That's 0.804. And the final one, the probability that x lies between 1 and 7 strictly, the way I'd calculate that is the probability that x is less than or equal to 6, take away the probability that x is less than or equal to 1. So that means one of the things that are in, you want 2, 3, 4, 5 and 6 to count, so you count the probability of 6 or less, and then subtract 1 or 0. So you can read both of those off from the table. That's 0.9957 minus chance of x being less than or equal to 1 is 0.0196. 0.196, which is 0.7997, which would be 0.800 to three significant figures.